This conference will now be recorded. This conference will now be recorded.
Hi all, did you see my screen?
Yes, sir.
Yes, good to go. So first of all, again, thanks for joining the session. So this is my third section. So just I'm going to the Snowflake PPT, and whatever the last two classes we discussed, we'll just uh, review that again, and then we will go with the next thing, that is why Snowflake. Today the agenda is why Snowflake. Why Snowflake? So now this is continued PPT. Snowflake PPT. What is Snowflake? Snowflake is a cloud data warehouse on AWS, Azure, and GCP. Snowflake is a cloud data warehouse on AWS, Azure, and GCP. Simply, Snowflake is a software platform. So to do the query, to do some operations, or to make some query, or to do something, or to do some parsing, or to do some extraction, or to do some customization, we need a computing power. And to store some bulk of data coming from the different range of sources, we need a storage. This computing power and storage will be provided by a cloud vendors called AWS, Azure, and GCP. So Snowflake is just a platform which will use the query platform and the user accesses and metadata accesses and everything. So in architecture level, I will explain you very deeply about this Snowflake and cloud platforms. So as of now, Snowflake is a cloud data warehouse on AWS, Azure, and GCP. Any cloud you can use with along with your Snowflake software. So in IT industry, we need a resources. We have a firewalls, routers, switches, RAM, CPU, networking devices, storages, IoT devices, sensors. These all the resources will be maintained on company premises only. Company premises only. That we call it as an on-prem. So cloud, difference between the cloud and on-prem. So on-prem means all the resources will be maintained on the company premises. So whereas cloud refers to the servers that are across over the internal and the software and over the internet. Internal not, it is a internet. Over internet. The cloud refers to the servers that are accessed over the internet and the software and the databases that run on those servers. So that cloud refers to all the resources will be maintained on some other places. All the resources will be maintained on some other places like racks, servers contains applications and databases. So these applications and databases and servers will be accessed via internet with your user devices. user devices. This refers to a cloud. What is the drawbacks of on-prem and what is the benefits of cloud? Before going to that, I will just go with a data warehouse definition. What is data warehouse? A data warehouse is defined as a centralized repository of data stored from a range of sources within and beyond the enterprise. Anything. So it should be a cloud, it should be enterprise, whatever it may be, on-prem. The data will be coming from the different range of sources, will be maintained on one place called as a centralized repository known as data warehouse. So data warehouse. So data warehouses are in two types. One is on-prem data warehouses and other one is cloud data warehouses. You all know that what is difference between cloud and what is difference between on-prem. On-prem means all the storage and computing will be maintained on the company premises only. All the storage and servers will be maintained on the computing. Servers means computing will be maintained on the cloud, some other place, and via internet you can access. That refers to the cloud data warehouses. So now what is data warehouse? Simply see here I have some data sources like CRM, billing, ERP, flat files and other data sources will be extracted by using a ETL tool. ETL is nothing but extracting, transforming, loading the data into a target tables called a data warehouses. Once the data warehouse will be maintained the data with a different schemas and the data will be searchable like taken by a different people like reporting people, analytical people, data mining people, data monitoring people, and data analysis people, and data scientists will use that one to forecast and predictive analysis for their own business strategies. This is the workflow of data warehouses. Now drawbacks of on-prem. So you know that what is the on-prem and what is the cloud. So in this case, what is the drawbacks of on-prem? Yes, need use capital requirement to purchase physical hardware. So you need to invest more money to purchase a physical hardware. Limited scaling also will be available. So for example, you see here limited scaling. For example, you bought some 50 TB of data, 50 TB of storage. So unfortunately, you are getting 75 TB, but you have only a 50 TB. So that's why we have a limited scale. So use infrastructure required. You need to maintain the infrastructure and you need to make some room and climating temperature and everything. You need to keep one admin. Everything infrastructure will be created by you only. Time taken. For example, let's say one operating system take 1 hour time to install on one computer. So if it is 1000 servers, so totally 1000 into 1 hour, 1000 hours it will take. So like that, it will take lots of time to install the softwares and operating systems and some other things. Whereas waste of resources, for example, you brought 50 TB, you brought 50 TB of storages. Unfortunately, you are getting 30 TB of storage. So what will happen? Whatever the remaining 20 TB will be wasted. So that's the major thing. And also latency issue. For example, your data centers are in India. Data centers are India, but users are in USA. So they are very far to the India. So while searching the data, some latency will come. Some latency search will be there. So that to avoid that latency issues also, we don't use on-prem. Maintenance overhead, anything will be problem, you need to take care of everything. If anything happened to your data center, that will be collapsed, no disaster recovery also. So that is the major important points here. So these are the most important points. And now cloud. Coming to the cloud, no investment. We just take the account of AWS cloud or Azure cloud or GCP cloud. No limited scale. Whatever the usage, based on your usage, they will allocate your servers. Scalability will be there. Use infrastructure required. No need. A basic laptop is enough to connect to your servers. Time taking to installation. No need. Already it was installed. We will just run the images. Waste of resources during ideal. No need. Whatever the usage you are using, for that only you need to pay. So latency issues, no need. Why? Because they have a different regions to set up their data centers. You can select your own region based on your project type. Maintenance overhead, no need. They will take care of everything. Disaster recovery, yes, they will give you high availability also. Even though one data center will be collapsed, they will give you high availability on next data center, and they will give you access on next data center. Why? Because they will maintain the replication copies to the next data center, so that even though one data center will be collapsed, you will get 100% of data. Next. Okay, we have a data center, we have a on-prem cloud, on-prem data warehouses and cloud data warehouses. I said that it is better to go with the cloud data warehouses. Now, why cloud data warehouse called Snowflake? Why cloud data warehouse called Snowflake? We have lots of links are there: Amazon Redshift, Google BigQuery, Teradata, Azure Synopsys. Like that, we have lot many competitors are there for Snowflake. Why? 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 The first point is hybrid architecture. Hybrid architecture. First point is hybrid architecture. And the second point is storage. Storage. Columnar storage. Hybrid columnar storage. Hybrid columnar storage. And the third point is automatic optimizers. Automatic optimizers. Optimizers. Fourth point is computing and storage are separate or individual nodes. Individual nodes means separate. Fifth point is time travel. Sixth point is file safe. File safe. FAIL. Seventh point is tasks and streams. Tasks and streams. Eighth point is shared. This shared nothing in this MPP columns. Massive parallel processing. Eighth point massive parallel processing. Query processing. Query processing. MPP. Masu. T size compute. Micro partitions. Micro partitions. Ninth point is choose your own cluster size. Cluster size VMs, virtual warehouses. Virtual warehouses called as computing. Called as computing. Okay. Next, zero copy cloning. Very important point. Zero copy. Task data sharing. Zero copy cloning. 10th point is zero copy cloning. And the 11th important point is data sharing. Data sharing for Snowflake accounts and non-Snowflake accounts also, and non-Snowflake accounts also. Snowflake accounts also. Micro partitions. Important. It is enough. First one is hybrid architecture. Shared disk and shared nothing disk. So it consists of shared disk and shared nothing. Shared disk and shared nothing means, anybody knows about it? Shared nothing architecture. See here. Shared disk and shared nothing architecture means this is the shared disk and shared nothing architecture. So shared, this is our store shared. Just to save image, just to desktop, and just save it. In detail, I will explain in next class. Just I am saying that I am just simplifying that why we are going with this plan. The major important is shared everything. So shared disk and shared nothing. Storage is divided into two types. So shared disk and shared nothing. Shared disk means, for example, the shared storage will be combined with the different nodes, and then the data will be shared to the different nodes. Whereas shared nothing means they are working with the individual nodes and they are connecting with a network, and that will be connected to the master. Okay. Shared disk means within the nodes it will connect it. That means it's a combinedly shared everything within the nodes. Whereas shared nothing means they will work with the individuality, and they will share, they will make a connection with the networking only, and they will make communication with individuals, but it won't share anything. It will make individual nodes, and then master will respond and give us both shared disk and shared nothing. Both architecture will be used by Snowflake. That is the major important thing. This is their architecture. See here, why Snowflake means architecture, hybrid architecture. That is the one most important point is hybrid architecture. Why people, even Amazon people having a Redshift, even Azure having a some Azure Synopsys, even a BigQuery having a Google having a BigQuery, a Teradata having a cloud. Why they are using a Snowflake? Even people are looking for Snowflake instead of all these things. Why? Because the major first point is hybrid architecture. That means shared disk and shared nothing elements will be the architecture of your Snowflake. Both will follow. Whereas Redshift only shared nothing. MPP architecture, yes. Even Snowflake will be MPP architecture, massive parallel processing architecture. In detail, we will go with the next class. Whereas BigQuery only shared nothing MPP architecture. Whereas Teradata shared nothing MPP architecture. Whereas Azure shared disk MPP architecture. Shared disk Azure. But Snowflake will support to the both the architectures like shared disk and shared nothing classes. Okay, that's a major first important point. That's why, and remaining almost all are same, like more serverless, more self-management, serverless, more self-management, more self-managed, cloud-based, 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 cloud-based. High, good, high, okay. Whereas scalability is scalable horizontally and vertically, both will work. Horizontally and vertically we can scalable. What is horizontally and what is vertically we will see on next classes. Security, high secure, no problem with that. But hybrid architecture will be the major important point why we are going with a Snowflake. Clear? Next. Second point, massive parallel processing. What it mean by massive parallel processing will be discussed on next classes, but just a definition, massive parallel processing. So massive parallel processing means it is coordinate processing of program by multiple processes that work on different part of the program. Massive parallel term uses a large number of computer processes to simultaneously perform the set of coordinate computing in parallel. GPUs are massive parallel architecture with 10,000s of threads. That is the definition. So massive parallel processing means at a time completely. For example, thousands of nodes will be processed at a time. Massive parallel processing is a storage structure designed to the handle of coordinating process of program operation by multiple processes at a time. This coordinate process can work on different parts of program with each process using its own operating system and memory. This allows MPP database to handle massive amount of data and provide much faster analytics based on the large data sets. MPP processor can have up to 200 or more processor work on application and most commonly communicate using a massive messaging interface. The simple massive paralleling is nothing but complete cluster. So thousands of nodes will be combined as a one node and it will process our data with fast and good performance. That is the massive parallel processing. Whereas storage, very important storage. Snowflake follows the hybrid columnar storage. What it mean by hybrid columnar storage? Do you know the hybrid columnar storage? Do you know anybody knows about hybrid columnar storage? Anybody knows hybrid columnar storage? For example, you have a big file. You have a big file. I will have one diagram already. I will open that diagram so that it will be used. Just click on Snowflake. So what will happen is here. hybrid columnar storage. So what will happen in hybrid columnar storage? For example, if you have a big file with lakhs of records, and this file consists of some, for example, 1 GB size, 1 GB size, for example. So in this big file, what will happen means, if you try to search the data, or if you try to search the data like select a star from, okay, if for example this is a table, ID, name, salary, gender, department number. For example, you have a 10,000 records, 10,000 records. If you search for the select a star from employee table, select a star from employee table, where ID greater than 5,000. If you search for that, so the data will be searched on particularly on that row partition. Yes, sir. So for example, what will happen? For example, as I said, like this is your table. Please listen carefully. This is very important. So this is your table. You have an ID, name, salary, gender, and a department number. Very important, please. Here, for example, I have 10112. So I have these many records are there. Same like that, I have different columns are there. So like for example, these many records are there. This is my table, for example. This is my table. Now, for trying to search for the data, like for example, select star from employee table. Select star from EMP table. This is EMP table. So that time this search will be run faster in this query table. Why? Because faster. Why? Because there is no restrictions. There is no restrictions here. There is no restrictions here. Why? Because it directly search your table and it will give a result. But whereas, for example, this is my query, select ID, salary, and department number from employee table. Now this is slower, somewhat slower. Okay, somewhat slower. Where is this query? Select star from not ID, salary, and the department number from employee table. So in this case, I want to filter columns. I want to filter the columns, whereas some databases will follow the row partitions. This is a row partition. Some databases will follow the column partitions. So some databases follows the row partitions. Some databases will follow the columnar partitions. Column see. Columnar partition. Columnar partition. So in this case, if you are trying for the entire table, it is giving a entire table, nothing will happen. Whereas select ID, salary, row number, that time that partition will be in columnar, that will be a faster. But if it is in row partition, the data will be retrieving slower. In this case also, if you select something like select statement, if you select select ID, salary, department number, and from employee table. So it is a mixing of table where ID greater than or equals to 5,000 and department and salary less than or equals to some 50,000. I want this condition. So here you need to remember one thing. This is the columnar partition. If you follow this columnar partition, you will get fast and efficient results. But if it is a row partitioner, you are checking for the all rows, you will get fast and efficient results. But this is a combination of row and columnar partition. See here, you are checking for the special columns, special condition based row conditions. So it is a combination of rows and columns. So that time this columnar partition, this row partition and this column partitions was not work. So in this case, so we will use a row columnar partition, hybrid columnar partition, columnar partition. So this will helpful to get faster. It is faster. It is faster. Why? Because it is both having a row split and a column split. So for Snowflake follows this columnar partition. So somewhere like this, for example, you have a big file, part file with 1,000 records. What it will create? It will create a row partitions with a different micro partitions. So there we have a concept called micro partition. So that micro partition will be created. So micro partition is nothing but it will be divided into small chunks. Whatever the big file won't be like that. It will be created as a small chunks. Okay, small chunks like this. See, this is one chunk, this is one chunk, this is one chunk. This is small part of chunk means small part of file. So it is small part of file for the big file. It is the small part of file for the big file. It is the small part of the file from the big file. Like that, it will create a micro partitions. This is one of the best thing also. This is also one of the best thing. See here. Here is this micro partition. Micro partitions is also one of the best one. So micro partitions means a big file will be converted into small parts of chunks. So it is automatically, no need of doing anything. Snowflake will do automatically. Okay, based on the requirement. Okay, that's the one of the best benefit here in the Snowflake. So in other data warehouses, it won't be like that. So what is the benefit? You are creating a small chunks from the big file. So we can create a different columnar partitions, hybrid columnar partitions like row partition. For that row partition, for example, it is a big file of 1 GB. So it is for 10 MB, 100 MB, and this is for 100 MB. 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 Like that, 10 files. According to Snowflake, it will create some small files. Like depends upon their requirement, they create some 10 files. Example, 10 files. So in the 10 files also, it will create a row partitions and column partitions. This is entirely row partitions for 101 to 300 row partitions, IDs, and column. What is columnar partition for ID? What is a columnar partition for name? What is columnar partition for salary? What is columnar partition for gender? And what is columnar partition for department number? Same that second row partition will be created. For that, columnar partition for ID, name, salary, department, and gender. Again, you will create a one more rank row partition 3. So 600, 500 to 700. Okay, columnar partition for ID, columnar partition name, salary, gender, and so. And then again, you create one more row partition 4, 700 to 800 records. 700 to 900 records, columnar partition ID, salary, name, like that. It will create a hybrid columnar partition. Now, if you try to search for condition based also, it will connect to that particular specific chunk, small part of the file, and it will give fast and efficient results. That's why the data in the process, Snowflake query process will be a very faster with the help of hybrid columnar storage. Why? Because it will create a different chunks. So it will directly connect to that particular chunks and it will retrieve the data from that chunks. Okay, so that it will be a very faster on searching, and it is very easy to maintain the data into different storage parts. That's the one of the major important point. Next, storage automatic optimizers. As I said, like automatic optimization. For example, if you write a query for one condition with the same condition, I written one query and you written one query, but your query will be executing for next 1 hour, but my query is executing for next 15 minutes only. Why it is? Because query problem. You written some complex query on it, but I written some simple query on it. So Snowflake automatically optimize your query and it will give faster on query processing. That's the best important point. And then computing and storages are individual nodes. As I said like previously, so computing and storage is different. Why? Because see here, so if you talk about a computing, so previously what will happen means, so it will come under this one node. Okay, like this. So like this it will come. So this is a storage and this is a computing. For example, 20 GB storage and the 2 GB RAM, for example. So it will call it as a one node. But in Snowflake, what will happen means there are two individual nodes. So if you want to change, if you want to increase individually, it will be increased. For example, 20 GB and this is 2 GB. So like that. So if you want to increase the storage, you can add a one more node for storage. If you want to increase the computing power, you can add a one more node for computing power for this node. Like that, individually it will be added. That's the major important point here. That is, to computing and storage are individual nodes. What is time travel? Time travel means, let's say for example, last 10 days back you just wrongly updated some table. So if you want to change that one, what do you need to do? You need to go back there and you need to change some modifications. So that will be happened in this Snowflake. So you can go and time travel on next 90 days. So 90 days, up to 90 days. So up to 90 days back. Up to 90 days back, you can travel and you can change modifications on that time travel option. File save. After 90 days also you want to change something, so extra 1 week we will get, but you need to take support from Snowflake. So this is the major important thing. Task and streams. Yes, if any changes will be happened on the next previous queries, so that will be captured and that will be scheduled also. And every day, every month, every 1 day or every day 10 AM you need to schedule it. You can schedule it also. Micro partitions, you can create a micro partitions also. Like compute clustering in virtual warehouse, I will explain this one. In virtual warehouse, we have a separate class for virtual VMs. Okay, virtual warehouse. Virtual warehouse. We have a separate class for this virtual warehouse. I will explain later on this virtual warehouse. And zero copy cloning. Actually, we are not creating any copy of data here. So why? Because Snowflake won't maintain any data actually. So why? Because Snowflake will maintain only the metadata here. See here, this is the hybrid columnar storage. See here, like this, we have a partitions. This entire data will be maintained on the S3 buckets on AWS Cloud or Azure or GCP, and only Snowflake will maintain the metadata. So metadata. Once you search for the query on Snowflake, it will connect to the metadata, and metadata will point out your raw data called any storage block. So this is what metadata. Actually, I'm hurry on this class. Why? Because I have an interview on 11:30. So I'm sorry for this actually. So I will explain entire this topic on next class. I'm sorry. I'm extremely sorry for this. So I have a class. I have an interview on this time. Okay. So this is the one of the major important metadata. It will maintain the metadata. The third last mode is data sharing. You can share your data with Snowflake accounts as well as non-Snowflake accounts. Non-Snowflake accounts. You can create reader account and you can share it. That is the major important point. That's why we are going with the Snowflake. Again, I will brief this on next class. Again, I will brief this session on next session, next class. No questions on today. No questions. I will give you time on tomorrow. Thank you. Bye bye.